Assalamualaikum and hello. My name is Nur Amira Shazanani binti Muhammad Aminuddin and my metric number is 191312600.
Assalamualaikum warahmatullahi wabarakatuh. I'm Nishkila binti Ma'azali.
I'm Nur Najwa binti Muhammad. My metric number is 191313244.
I will explain about the introduction of this project. The practice of using computer software to mimic a product performance to enhance its design or make engineering challenge easy to solve is known as a computer-aided engineering. This software programmers simulate process, validate them, and improve manufacturing good and process. Pre-processing, solving, and clean pool processing process often make up the CAE process. Finite element analysis is frequently used to reduce the physical execution of experiment and improve design. The picture shows that the fully designed to describe the real situation. The entire view of mounting a bracket to support a pole. This bracket will support the weight at the end of the bracket. That means at the right side, which is presented by a pole of 274.6 Newton.
The objective of this project are to create a brand new geometrical and lightweight mounting bracket and to identify the ideal material for bracket design. In this project, we have three types of method that we have identified. Firstly, the 3D geometrical models, which is SolidWorks models. We identify about the material and mass of the bracket, which is less than 3 kg. Second, the 3D finite element analysis models development use modern computer hardware and software and utilizing ANSYS software. In this part, we also create a flowchart. Lastly, we do meshing to get von Mises stress and total deformation values. This method is determined using tetrahedral finite element discretization.
For the part of modeling, the modeling part is a draw or design use SolidWorks. There are several requirements that must be met when creating the bracket design. One of which is that the mass of the bracket must be less than 3 kg. The picture on the left shows that the design before undergoing change. The first design is used to alloy steel for the material for the bracket and show that the mass value over 3 kg. That means does not meet the condition set. This problem will convert the material to the titanium alloy and show that the value of mass 2.5 kg and not over 3 kg. To minimize the value of mass, we make the change to the design bracket shown in the right picture. The value of mass show there is 1.9 kg. Use the same material. Meshing or element discretization. After reaching the condition set for the value mass, this step is to determine the number of elements must not exceed 120,000 with a mesh size is 3 mm. In the picture, bracket is set as a tetrahedral element with a 3 mm size mesh. According to the research done on the design bracket, a mesh size of 3 mm produce 16637 element and 30069 node. That means this bracket can be used to the next step. Loading and boundary condition. The left picture shows the location of loading and the picture on the right shows the location of the boundary condition. The force imposed on the position of the node is referred as a loading. The loading in the type finite element below is force. The force value of the location of loading is 274.6 Newton. The horizontal hole on the left and the vertical hole with a diameter of 10 mm both fall under the category of sites that are susceptible to the boundary condition. Result for the linear static analysis show that there are two results, which is equivalent 1 meter stress and total deformation. The maximum value for the 1 meter stress is 59.188 megapascal, and the maximum total deformation is 0.8557 mm. The table below shows the criteria set for the maximum deflection of the bracket is not exceeding 1.5 mm. From the result obtained, show a total deflection is not exceeding 1.5 mm of 0.8557 mm. The below formula show the work to get the value of the factor of safety. The conditions set for the FOS are over 2. The value of the FOS obtained is 13.98 megapascal.
This figure shows about the result of the 1 meter stress by thermal stress analysis. According to the result, the maximum value of the 1 meter stress is 159.99 megapascal. It's located at the 4 holes on the bracket. At the same location, present the red region. It's represented as the critical location. It can be assumed the critical location occurred because there was weak support applied. The total deformation occurred as shown by finding of the thermal stress analysis in this figure. The maximum value of this result is 0.85197 mm. The red region shown the critical location due to the presence of a force that was being applied to be 274.6 Newton, and it happened at the end of hole of bracket.
For the result of free vibration analysis, this is the natural frequency transition from mode 1 to mode 5. Each mode of natural frequency will be represented by 5 total deformation response characteristics. Total deformation that represents deformation for mode 1 is simple bending. The maximum value of total deformation recorded is 3030.2 mm with the frequency of 8394.9 Hz. Total deformation 2 that represents deformation for mode 2 is transverse bending. The maximum value of total deformation recorded is 2927.1 mm with the frequency of 41,510 Hz. Total deformation 3 that represents deformation for mode 3 is bending at middle span. The maximum value of total deformation recorded is 4,248 mm with the frequency of 50,551 Hz. For total deformation 4 that represents deformation for mode 4 is twisting. The maximum value of total deformation recorded is 3,393.9 mm with the frequency of 54,073 Hz. Lastly, for total deformation 5 that represents deformation for mode 5 is bending at quarter span. The maximum value of total deformation recorded is 6,952.4 mm with the frequency of 1.312 exponent 5 Hz.
The table below shows the criteria set for the maximum deflection of the bracket is not exceeding 1.5 mm. From the result obtained, show a total deflection is not exceeding 1.5 mm of 0.8557 mm. The below formula show the work to get the value of the factor of safety. The conditions set for the FOS are over 2. The value of the FOS obtained is 13.98 megapascal.
To investigate the thermal stress analysis need two conditions of the temperature, which is initial temperature ST1 equal 25 degrees Celsius and final temperature is raised to 52 degrees Celsius ST2. During this situation, the temperature has been raised. It means the bracket will make deformation, which is the dimension of bracket expand. This happens because generally when temperature increase, it tends to expand, and when the temperature decrease, it starts to shrink. This bracket has been constructed as safe product because the factor of safety is greater than value of 1, which is 5.17. Then from that, we can compare the result from the thermal stress analysis and without thermal stress analysis. Based on the table below, shows a significant between in the maximum value of 1 mesostress from these two analyses. The difference in value of 1 mesostress from these two analyses is 100.802 megapascal.
The pattern of deformation that will occur when the excitation corresponds with one of the system's natural frequencies. The structural mode shape is the name given to this deformation pattern. The structure we construct now has the natural frequency and form of this mode. The structure's weight and stiffness are the factors that govern where the frequency and natural shape of this mode will exist. This result is useful if the form of the mode and how the structure vibrates when excited can assist the design engineer in designing a better structure.
Analysis has been done to look into how to make a new geometric mounting bracket from a new material called titanium alloy. There are three types of analysis has been done, such as linear static analysis without temperature, thermal stress analysis with temperature, and free vibration analysis in 5 modes. Based on the result of the linear static analysis and thermal stress analysis, the maximum value of 1 mesostress and total deformation both happen in same location. In these two analyses, the maximum value of 1 mesostress is at the 4 holes of bracket, and the maximum value of total deformation is at the end of the bracket holes where the load is applied. After all the analyses were done, it was decided that this design is safe because the design and material were chosen based on the factor of safety calculation, which shown the value is greater than 1.